All right, focus up, people. This is Scott Wilson with Dumbass Contractors checking in. Welcome to today's briefing. Our topic is what is work. All right, we're doing a lot of tests here. Distance from the router, lav mic. Let's see if it works. Don't expect anything big today. We're just going to run through this. All right, this is one of the first lessons every guy that comes through my shop gets. It's universal, happens within the first week. All right, this is not my work. This is John Amstein from my high school physics class. All right, what I do is I ask my guys if they can read this. W equals F times D. Now, about 10% of you are going to raise your hand that you've seen it before. Only 1 or 2% of you are going to actually be able to read it. All right. And W equals F times D doesn't count. This is the formula for work. All right. Work equals force times distance. All right, so if I have a brick wall and I lean on it all day long and that brick wall does not move, how much work have I done? If my distance is 0, but I've exerted 100 in force, how much work have I done? 0, because anything times 0 is 0. All right, force equals mass times acceleration. All right, acceleration. This is important. All right, you've heard me talk about acceleration before. How do we generate it? How do we achieve it? If we're driving a car, we can hit the gas pedal and the car will accelerate. How do we do that when we're doing work? All right, so we can shorten that formula down to work equals mass times acceleration times distance. Let that sink in for a minute. Work equals mass times acceleration times distance. All right, so if I could do tiles, we'd have some visual aids here and that would keep your interest more, but this is a warm-up. We're going to do this video 4, 5, 6, 7, 8, 9, 10 times. My guys hear it all the time. We talk about acceleration because acceleration is important, and I'm going to show you why here. I did a retaining wall at my house in New York. There were 1,200 blocks in that retaining wall. We had to insert 100 yards of backfill. I used recycled concrete aggregate for that backfill. And we had to dig a trench 125 feet long, 4 inches deep, 2 feet wide. All right, so all the spoil came out of that trench. We had to backfill it with block because we had to go down below the frost line with the wall. We built 125 feet of wall, and it needed a trench underneath it. All right, so we had about 250 tons of weight that had to be moved, an average of 50 feet. Now, we couldn't get any machinery in there, so it all had to be done by hand. When we do tiles, you'll see why. It'll all start to make sense. All right. An average of 50 feet, 250 tons. These are given. All right. These are constants. Those did not change. The only thing that we could affect was acceleration. How fast could we move that material? How fast could we stack that material? How fast could we backfill that material? How fast could we dig the trench? All right, my guys will hear me all the time. Let's do it. I use keywords and tricky phrases. Let's kick this thing into hyperdrive. That's acceleration. Pedal to the metal. That's acceleration. All right, acceleration. I want to accelerate the process. I had 4 men, 12 weeks, or it would have taken 1 man 250 days to build this 1,200 block retaining wall. All right, so we moved this 250 tons of weight, 50 feet in 12 weeks, 4 of us. The only thing that I could affect was acceleration. And that's teamwork. It's getting guys, putting them in the harness every morning, letting them pull all day long. And at the end, give them a cool down walk at the end of the day. Do it again the next day. Discipline, day in and day out, not changing a thing for 12 straight weeks. 3 months we were on that project. All right, that's just the wall. Didn't include the railing, didn't include the AstroTurf that we put on top of it. During COVID, I did a lot of step work and stair work. But to stack these 1,200 blocks, move these 1,200 blocks 100 feet down to the job site, stack them properly, bring in 100 yards of backfill, because we made an extra tier, an extra terrace, 125 feet long. The only thing that we could affect was acceleration. Work. You lean against that wall all day long and that wall doesn't move, 0. You move 250 tons of weight, that's your mass. You move it 50 feet, that's your distance. Your acceleration is going to be 12,500 foot tons. That's how we calculate it. Could be tons per foot. Foot tons of pressure, foot tons of acceleration. It's a lot, carrying all that stuff down by hand. 250 tons of weight. 4 guys, 12 weeks. 1 man, 250 days. Now, I don't think that 1 man could have done this in 250 days. I think it would have been 350 days for 1 man. By running a 4-man crew, one of the ways that I could create acceleration was not getting guys jammed up moving this material, moving this 100 yards, because we could only insert 3 yards a day. By the end of the job, we were inserting almost 5 yards a day, but still, it would have taken 20 days just to get this material in. All right, so 12 times 5 is, so we had 60 days in it. 20 of those days, we inserted 5 yards. All right, and it took us a while to work up to where we could understand what to do. One of the ways that I achieved acceleration was by not putting in the wrong material. Everything had to be sequenced properly. All right, that's important, sequencing. If I realized that the site was so complicated and there was so little room to work and to store stuff, that if I inserted the wrong material, or if I had the wrong material delivered at the wrong time, that I would slow the whole process down. All right. One of the things I had to have it inspected by the town engineer at specific points. How was I going to keep the project moving forward with the acceleration I had already achieved while I was waiting for that inspection? Now, Town of Huntington accelerates these inspections for me, but I would call and still have there would be a delay from when the engineer could get there and look at it. All right, so what we would do then is start digging another piece of the trench. I had to dig the trench in 4 sections. I couldn't look at the sections. I couldn't put my builder's level on all 4 pieces of it. So I had to build it in 4 separate sections. And I had to have points that I could do my math off of. An incredible amount of math to get this project to work out right. So we built the outer tier and then the upper tier. All right, we built it in 4 sections. But but the hill was so steep that we couldn't shoot grade everywhere. You'll see how complicated the site was. Okay, so I built this section. We started off building this section. It was actually looked more like this. We built this section, then we built on top of this, and then we built this section and this section. These corners were woven for strength. This corner here went down 14 feet. So it was a complicated stack, and there was an 1/8 of an inch difference in the material. We used Versalock on it. Okay, acceleration. How could we achieve? The easiest way to achieve acceleration is to not need it. Don't get in your own way. There were 4 of us. We're constantly thinking about how to keep ourselves on track. My guys we were really focused on staying productive, and it worked. That's a lot of work to put out in 12 weeks, 4 guys. We had a lot of rain. Well, a lot of times it rained in the morning till 10:30 or 11. We'd sit in my shop, drinking coffee, telling stories, and then we'd hit it hard for 6.5 hours. It's the only way that we could do it. We were up to our knees in mud, but it was tough. And it was dangerous too, because right here, this was 14 feet. 14 feet of wall in this corner. Wet, rainy year. My house kind of sits in here like this, and all of this is getting ready to fail, which meant my house could have slid down the hill if I didn't do this retaining wall. All right. Work equals force times distance. Distance is important. If you push on that wall for 8 hours and that wall doesn't move, you have done 0 work. You've expended a lot of force, but you've achieved no acceleration because this distance hasn't moved at all. All right, so that's 0 work. All right, we're gonna do this with tiles. Computer's still a little slow. I'm guessing at what it's doing. Microsoft wanted to do me a favor and upgrade my software on my laptop. Let's see what happens here. All right, guys, work equals force times distance.